Pre-Algebra, lesson 123. This is the final lesson in the book, and it's also one of the first lessons that you learn in Algebra 1. This is numerals and numbers, the subsets of the real numbers. So let's clarify. A number is a mathematical, a number is a logical idea, right? So for example, the idea of 3 can be represented multiple different ways. This is nothing new. It's something you guys have heard me teach about for quite a while now. Whereas a numeral is simply the symbol we use to think of the idea. So for example, the symbol 3 is not the same as the number 3, okay? So it's very important that we distinguish between numbers and numerals, because numbers are ideas. And then, they're going to go through something that I've explained to you guys so many times, which is they talk about the many different ways to write the number 3. I could use this numeral, I could use this, but then again, this is also 3, that's 3, that's 3, that's 3. All of these are different ways to write the number 3, okay? So a number is an idea. The idea can be represented a lot of different ways. And a numeral is just a specific symbol that we use to recall that idea. Okay, so it's very important we understand the difference between them. Now, when it comes to the subsets of real numbers, we have to understand what a real number is. Okay, the short answer for what a real number is any number you can put on a number line, right? So if I were to draw a number line over here, right, on this number line, I could have the number 0. I could have whole numbers like 1 and 2. I could have negative numbers like -1, -2. I could have fractions. For example, I'll put some green fractions up there. Like here, that would be 1/2. Over here, this could be 3/2. I could have -1 and 1/2. Mixed numbers too. I could also do decimals. Right? We'll do decimals in red. So for example, I could have 2.2, or I could have -0.4, right? I could have decimal numbers, big or small. I could also have repeating decimals, like not at 1/2. Yeah, right there. I could have 1/3, which is also 0.33333 repeating, right? What other numbers could I fit on a number line? Okay, I could also fit some complex numbers we don't know. So like here's the number 3, here's the number 4. What special number do we know of that falls in between 3 and 4 that's like right around there and also related to the circumference and area of a circle? Right, I could put the number pi, because pi is approximately 3.14, right? So all of these are real numbers. Any number I can put on a number line is a real number. I could also put square roots. Like for example, right here at 0.4, I could also put square root of 16. That's the same number, right? And we've also done experimentation with the different square roots. So like for example, if I were to put the square root of 12, I know that would fall in between 3 and 4, because the square root of 9 would be 3, right? So we've done problems like that. I don't know exactly where it is, but I know it's somewhere in here. So all real numbers. Now let's talk about how to categorize them. Now to do this, I'm going to do something super cool. I'm going to project my screen. Where is it? There it is. Okay, I'm going to project my screen and we're going to learn numbers. All right, so this is the flow chart that you see on page 393, but this is my way of explaining it. So when we classify numbers, numbers can get really messy, and sorting these ideas is very, very important, right? Messy like many of your bedrooms, okay? Yeah, there you go. Messy room. That's kind of like our view of numbers right now, right? As a child, you've got all these numbers on that number line. It's like the one I just drew, where they're all smashed up together and we don't really have a way of sorting them. So we're going to start sorting them so that way they're not so jumbled. So the way we classify numbers goes into 2 groups. To the left over here, we have real numbers, and then to the right, we have non-real numbers, okay? We're not going to be learning too much about non-real numbers, right? That's more of an Algebra 1 thing, right? But they include ideas like infinity. They include ideas like imaginary numbers, which you learn about in Algebra 1, imaginary like Bing Bong. And they're kind of written like this. We don't have to worry too much about those yet. But what we do have to worry about is real numbers. So this chart in your book is real numbers. We're going to see this breakdown. So real numbers, like I just said, they include just about all numbers: negative, positive, whole, decimal, fraction, special numbers like pi, other numbers you haven't even learned yet like e. Yes, e is a number. And they're all over the number line, just like I drew. Now, these real numbers are broken into two groups. On the left, we see the group of rationals. On the right, we see the group of irrationals. We'll start with irrationals, right? So the concept of irrational numbers are numbers that cannot be expressed as a simple fraction. So, and then they're also characterized by non-repeating, unending decimal forms, which means they're decimal numbers that never end and never repeat. Okay, so that includes numbers like e, pi, square root of 2, square root of 3, things called natural logarithms, which you don't know yet, but these top ones we know, pi and imperfect square roots, right? The number pi, 3.14, etc. It goes on infinitely, and the numbers never repeat. Same thing with imperfect square roots, like the square root of 2. That number never ends. It just goes on forever. If it's not a perfect square root, it never ends. So those are irrational numbers. Now, they're not to be confused with imaginary numbers, okay? So I is imaginary, pi is rational, right? So, or pi is irrational. So imaginary is not real, pi is not rational, and those are numbers. That's how numbers make fun of each other. All right. Irrational numbers, numbers like pi, numbers like imperfect square roots, okay? And then there's a chart of how the imperfect square roots just go on forever. All right. Now let's see here. Checkpoint. Okay, so quick recap. We talked about real numbers. We talked about rational numbers. We talked about irrational numbers. Now we're going to go on to rational numbers. Okay, so rationals, that's what you actually see on the right side of your book. Rational numbers are numbers that can be expressed as simple fractions, and they include most normal numbers that we commonly use, right? So those are numbers like 25 over 5, 4 over 5, 0 is a rational number, negative 1.5 because I can turn that into a fraction, and then you also notice we have negative 6.3 with a line over. So rationals also include perfect square roots and decimal numbers that repeat infinitely, right? Whoops, too far. So if we have perfect square roots like square root of 1, square root of 4, square root of 9 that end in perfectly whole numbers, or if we have numbers like negative 6.3 repeating, if we have repeating decimal numbers or perfect square roots, those count as rational. All right, now let's see here. Final lap. Okay, so this is the last step. We're going to figure out three groups of rational numbers. These three groups are counting numbers, whole numbers, and integers. All right, so these groups of numbers kind of progress with history. So counting numbers were the first types of numbers invented, and they're things that you use to count anything. Now, when you use counting numbers, you don't start with the number 0. If you're going to count items, you always start with the number 1, right? So for example, scoops of ice cream on a cone. Mr. Claiborne likes 6 scoops of ice cream, okay? Just so you know, for future reference, I don't want 5, I don't want 7, I definitely don't want 2 or 3. I want 6 scoops of ice cream, and that's how I would count them. 1, 2, 3, 4, 5, 6 scoops of ice cream. That's counting numbers, okay? Now we have whole numbers. Whole numbers are like counting numbers, but they invite 0 along for the party. And you guys have probably heard me talk about how people argued over the number 0 for almost 1,000 years across the planet as to whether or not it should be a real number. The Greeks didn't think so. The Chinese thought so. The Egyptians were kind of like, maybe, not really. You know, they kind of had a symbol for it, sort of-ish. But they didn't really have an idea of it. So whole numbers include 0. So it's just 0, 1, 2, 3, 4, 5, 6, 7, 8. Now the final group that falls under rationals is integers. Integers is all whole numbers and their opposites are negatives. So it's 0, all the positive numbers, and all the negative numbers. These are integers. So we see positive integers on the right, negative integers on the left, and the number 0. So integers are every positive and negative whole number. No fractions or decimals in the group of integers. All right, well, that's it for real numbers. We've got reals on top, rationals on the left, irrationals on the right, counting whole and integers. Congratulations, you guys made it. We now know how to classify numbers. All right, let's go back over here. Wow, how far did that? Oh, wow, we did that in less than 10 minutes. Okay, so that's classification of numbers. When it comes to your practice problems, they're going to want you to identify numbers. For example, 123.1, they want to know to which number sets does negative 3 and 2/3 belong. So if we look at negative 3, well, that's, if we go from the top of the chart, that's a real number. Is it rational or irrational? Right? Well, we would say it's rational, right? So negative 3 could be rational, and it's an integer, but it's not a whole number or a natural number because there's no negatives in those groups. Okay. Now, what about 2/3? Well, 2/3 is a real number, and it's a rational number, but it's not an integer, a whole number, a counting number, right? Because it's a fraction. But it counts as real and rational, okay? What about the number pi? What does that belong to? Well, it's a real number, Is it rational or irrational? It's rational. Okay, so it would just be real and irrational. So that's how you use this little flow chart. You start at the top with real numbers. You ask, is it a real number? Yes. And then from there, is it rational or irrational? Yes. And then you start putting those labels on it. Now notice irrational numbers, it doesn't have any more subgroups, but rational does. And that's part of why I show you this flow chart at the end. So you kind of see there's you see there's reals at the top, rationals on the left, irrationals on the right, and we can kind of see the way that it funnels down into the groups. If you guys have any other, so that's it for this lesson. If you guys have any other questions, let me know on the school website, and I will see you in class.